Hey, welcome back to Diary.io. In this video, we're going to get hands-on with SSH. You will be connecting securely to a remote server using OPENSSH. Let's get to it. A couple of things we need to get cleared off. First off, you'd notice I'd removed the previous server, which was called Ubuntu Desktop, and renamed it to Client. If you turn off your server, go to Settings, and under the general you can just type whatever name you want to call it, so that we can easily demonstrate how client connects to a remote server. It's quite important for us to give it a name that represents what we want it to do. Now, to get our remote server up, rather than having to download the Ubuntu ISO and go through all that long installation process, we can just make a clone of this, and by right-clicking and hitting on clone, I can just name this remote. Yeah, just remote is fine, and leave everything as default. We want a full clone, not the linked one. And that's gonna take a few seconds or minutes. Now that we have both client and remote, there's one more thing we need to do. Let's do the client first. Settings, and go to network. I'm not going to say a lot about network. We have dedicated videos on networking, but for now you can just do what I'm about to do. And what I want to do is to enable the second adapter and attach it to the bridge adapter. So the first one, adapter 1, is attached to NAT. I want the other one to be attached to bridged. And I'm going to do the same thing for the remote. And if you're very curious why I did that, is to have unique IP address for each of them, so I can specify the IP address to connect to the remote server. Okay, let's get both of them up. And I will put the remote on the right, put client on the left. Let's bring up our terminals for both of them. The first thing you notice is we still have client on both servers. Even though this is remote, it still has Diary at client, and that's because it was a clone of it. So the first thing I want to do is to fix that. To do that, I would use sudo to edit a configuration file called hostname. This file just keeps data about the name of the server, and I will save that. Reboot. Now we have our servers properly named. The first thing we want to do is generate our key pairs. Remember, SSH uses asymmetric cipher for encryption, and that means we need 2 keys in a pair. But before I create the key pair, I want to ensure that the folder where SSH keeps its data is currently empty, and that will be our home, the name of the user, diary.ssh. So every user have their own .ssh directory where SSH related keys are being stored for that user. And of course, for Diary to be able to connect to the remote, the user Diary also must exist, and we can confirm that with the ID command. So Diary on client is about to connect to Diary on the remote server. The command you need to run to generate the key pair is ssh keygen, ssh-keygen. It says generating public private RSA key pair, RSA being the encryption algorithm, and it's asking us, where do you want me to save these key pairs? As you can see here, it's trying to default to home diary.ssh, and the name of the private key is id_RSA, RSA being the encryption algorithm. If I wanted it to create it somewhere else, I could just specify where, like that, but I don't want it to go into temp. I'll just hit enter. Do I want passphrase or not? If I put a passphrase, that means every time I need to make use of this key pair, I need to specify some sort of password. And this is used for extra security for connectivity. But in some cases, you don't want to do this, especially when you're trying to use the account as a service account for your applications. And in such cases, it's called passwordless SSH or passwordless connectivity with SSH, however you think about it. So that's what I'm going to do. I'm not going to specify any passphrase. I'll just hit enter, and that's it. I'll clear my screen and do a list on that. As you can see, we have both files. Let me quickly show you what the content looks like. Let's print out the private key first. So that's what a private key looks like. How about the public key? The public key has extension .pub, and that comes in this format. Now that that is out of the way, the next thing we want to ensure is that the OPENSSH server is running on the remote server, because what we have is the client tool, and you can tell you have the client tool by running just SSH. You can see it's already coming back with some suggestions on how to use SSH. Obviously, I haven't passed any parameters to it, so that's just a client tool. But without the OPENSSH server itself, we won't be able to connect, because it has to listen to a connection. And by the way, it listens on port 22. That's the TCP port that it uses. So let's head over to the remote server and install the OPENSSH server software. Okay, we've got that installed. How about the SSH directory on the remote server? What does it look like? If I don't want to type home diary, there's a shortcut tilde, and tilde represents home diary. So if I do a list on that, let's use A to show me everything. And by the way, I'm interested in the .ssh. It's currently empty, so nothing is there. We didn't run the SSH keygen command here. This is where we run it. And that's why on the client we have both keys. So the number 2 thing we need to do now is to send the public key over to the remote host. We can connect to the remote host using the password. Even if a hacker hijacks the traffic and takes the password at that time to see the content of the public key, it doesn't matter, because we can share the public key to anyone. To make that transfer easy, SSH client tool comes with a program that helps us transfer the public key over to the remote host, and that will be SSH copy ID with hyphen in between them, and you have to specify -I, which means the identity we want to send over. And how do we intend to connect? Diary at. Now, do you think we can just type remote and then it understands how to go? Well, technically that's not going to happen, because this server doesn't even know who remote is, and the only way computers connect with each other is by using IP address. So rather than say remote, we need to get the IP address of this server. Let's see if this command works. ifconfig, that's the command we need to get back our IP address. There are two network interfaces here. You can ignore the last one, which is the loopback. What we're interested in is this one right here. If you check on your side, you'll probably notice that this is going to be the same as the client. It will have the same IP address as the client. We're not interested in that. The one that is different is what we're interested in. So let's paste that here, hit enter. Oops, the name of the file is not good. It's asking me, are you sure you want to connect? Yes, I do. I need to specify the password. One key added, and it's giving me the command to run to connect to the remote host. So let's minimize this. Clear the screen. Clear both screens. But before I try to connect, let's confirm what's here. Notice that there's a new file called authorized_keys, and that's where the public key is stored. Let's do a cat on that and do a cat on the public key over here. If you notice, they are exactly the same thing. There is 70YSFE here, 70YSFE, so we're good. Now we have private key here, we have public key here. I'll paste the connect command, and I don't need this here. And magic, look, we're connected from client to remote. So even though, let's minimize this. So even though this is the shell we've been using for the client, we're actually connected to the remote server. ifconfig, this is the IP address of the remote. Let's exit this, back to client, ifconfig. You'll notice that it's a different IP address on the client, 53159 and 53244. So that's how to connect to a remote host using SSH. But there are a couple more things I'd like to show you. So let's bring back our remote. And this is for administrative reasons. If you ever need to troubleshoot connectivity between two computers, as DevOps engineers or sysadmin guys, this is a very important step you need to really understand. First of all, there is a flag you can add to the SSH command if you really want to have more verbosity when it comes to making connections. And the level of verbosity also depends on the number of V's that you use. You could try with V or VV or VVV. And on the remote host, there's a file that you can use to watch what's going on. What is the remote server receiving? And that file is the log file for authentication, and that can be found in var log auth.log. The log does exist, so let me do a sudo tail -f. So the tail -f is basically saying I want to keep watching this file. Every new entry should just spit on the screen for me. And if I hit this, Two things you're going to notice is here we have some data here, and let's have a quick look at what's going on. It says accepted public key for Dare from this IP address. So if it didn't accept it, this file will tell you more about what's going on, and you can have an idea of why there is a problem when you're trying to connect from client to remote. And on the client, on the other hand, let's enlarge this. It does spit out a whole bunch of data on the screen that you can analyze and try to go through what's going on. So let's try a single. Actually, it's connected already, so let's exit and let's try single V. And you can see a bunch of things that's going on. It's reading the configuration data, and by the way, this is a file that you can use to configure SSH if you want to disable or enable remote connectivity or extend certain functionalities. You can find that file in etc ssh_config. So it reads that file and goes through a bunch of identity files as well. It checks the version of OPENSSH you have going on. It does some analysis on the encryption algorithm and quite a few things going on. So guys, this is SSH, this is how to connect remotely, and I hope this has been very informative for you. Don't forget to like and subscribe to the channel. See you in the next video.